Have you ever been playing a video game and just stopped to look around? At the way the sunlight filters through the trees, or how your character's feet leave prints in the snow? Think about your favorite game. You press a button, and your character jumps. You explore a vast city or a magical forest, and everything just works. It's so seamless that we forget it's not real. We get lost in the story, the action, and the beauty of the world itself. But behind that seamless experience are layers and layers of science, math, and art, all working together like a perfectly tuned orchestra. Creating that magic is one of the biggest challenges in technology. It's about building an entire reality from the ground up, one rule at a time. So where do developers even begin? They start with something called a game engine. You can think of a game engine as the foundation of a house and the toolbox you use to build it, all in one. It's a powerful piece of software that handles the most difficult and repetitive tasks, so creators can focus on being creative. The engine provides the basic systems: how to render graphics, how to play sounds, and, most importantly, how to handle physics. Without an engine, every developer would have to reinvent the wheel, coding the very laws of nature from scratch for every single game. Now, let's talk about one of the most important parts of that skeleton: the physics engine. This is where the world learns how to behave. In the real world, when you drop a ball, gravity pulls it down. It hits the floor, and it bounces. We understand these rules instinctively. A game world, however, knows nothing. It's a blank space. Programmers have to teach it the laws of physics using mathematics. This is gravity. It pulls things downward at a specific speed. They define properties for every object. Is this object a heavy rock or a light feather? Is its surface bouncy like a rubber ball or hard like concrete? When your character jumps, the physics engine calculates the arc of the jump based on gravity and the force applied. When you crash a car in a racing game, the engine calculates the impact, the damage, and how the pieces should fly apart. This system is constantly running, checking for collisions between millions of different objects every single second. It's a massive, ongoing math problem that makes the world feel solid, predictable, and believable. Without a physics engine, objects would pass through each other, and nothing would have any weight or impact. Every object you see in a game is made of simple shapes, usually triangles. These are called polygons. A simple object, like a cup, might have a few hundred polygons. A detailed character could have tens of thousands. These polygon models are like colorless, wireframe sculptures. To bring them to life, artists create textures. A texture is a flat 2D image that gets wrapped around the 3D model, like wrapping paper on a gift. This is what gives an object its color, its patterns, and the illusion of detail, like the grain on a wooden table or the rust on a piece of metal. But a textured model is still not enough. The real magic comes from light. Programmers place virtual light sources in the world, just like a movie director places lights on a set. The graphics engine then calculates how this light should interact with every single surface in the game. It figures out which surfaces are lit, which are in shadow, and how light should bounce from one object to another. It's an incredibly complex calculation that your computer or console has to perform 60 times every second to give you smooth motion. So we have a world that feels real and looks beautiful, but it's empty. Now we need to populate it with life. This is where artificial intelligence, or AI, comes in. Game AI isn't about creating a self-aware computer. It's about writing a set of simple rules that create the illusion of intelligence. Think about the enemies in a game. They need to know how to spot you, how to find cover, and how to coordinate an attack. Or think about the townspeople in a role-playing game. They have schedules. They walk to the market in the morning and go home at night. Each character is given a set of behaviors and a way to perceive the world around them, like a virtual sense of sight or hearing. Programmers use techniques like pathfinding to help characters navigate the world without bumping into walls. When these simple rules combine, They create complex emergent behavior that makes the characters feel alive and responsive. Finally, with all this technology in place, the artists and designers come in to add the final human touch. Writers create the story, the dialogue, and the history of the world you're exploring. And sound designers build the audio landscape, from the chirping of birds to the roar of a dragon. Each sound effect is carefully synchronized with the physics and animations to make every action feel satisfying. All these different disciplines, from coding to storytelling, must work together perfectly. This brings us to the big insight. A video game world isn't created with a single magic button. It is a painstakingly crafted illusion, built from millions of tiny, logical pieces. It's a universe governed by math, brought to life by code, and given a soul by art. Physics, light, and intelligence are not just concepts. They are systems that have to be designed, written, and optimized. The solution that game developers discovered was to break reality down into a set of solvable problems. How does gravity work? That's a math problem. How does light reflect? That's a rendering problem. How does a person think? That's a logic problem. So the next time you get lost in a digital world, remember the incredible blend of science and creativity that made it possible. You're not just playing a game. You're exploring a work of art built on a foundation of code.